A very good morning, friends. Today we'll continue lecture number 2 on method of induction and binomial theorem. Basically, this lecture is based on binomial theorem. So let us start binomial theorem. We will be doing proof of the theorem and then we'll start problems. The theorem is what? If a and b belongs to real number and small n belongs to natural number, then prove that a plus b raised to n is equal to nc0, a raised to n, b raised to 0 plus nc1, a raised to n minus 1, b raised to 1 plus nc2, a raised to n minus 2, b squared, and so on, plus ncn, a raised to 0, b raised to n. See the proof. We will prove it by method of induction. Yesterday in method of induction I told you whatever we have to prove that we take as a statement Pn. जो भी प्रूव कर रहा है उसको स्टेटमेंट Pn लेंगे. तो let Pn such that a plus b raised to n is what? nc0, a raised to n, b raised to 0 plus nc1. We keep on decreasing the power of a and increase the power of b. nc1 a raised to n minus 1, b plus nc2 a raised to n minus 2, b squared plus nc3 a raised to n minus 3, b cube plus ncn a raised to 0, b raised to n. Now you know in method of induction, first we will prove that it is true for n is equal to 1, that is P1 is true. Then we will assume that it is true for n is equal to k, that is Pk is true. After this assumption we will prove that it is also true for n is equal to k plus 1, that is Pk plus 1 is also true. Then by method of induction, the given statement Pn will be true for all n belongs to set of natural number. So let's continue to prove that P1 is true. Consider LHS of P1. A plus b raised to 1, which is same as a plus b. RHS of P1. Which is 1C0 a raised to 1, b raised to 0 plus 1C1 a raised to 1 minus 1, 1 into a into 1, b raised to 0 is 1, plus 1C1 is 1, a raised to 0 is 1, b raised to 1. which is A plus B. Therefore, LHS of P1 is equal to this implies P1 is true. Let this over state P1. P1 is true, we have to prove and we have proved. Now we'll go to what? Assuming that Pk is true. Let Pk be true. Pk be true means what? A plus B raised to k is what? Kc0, A raised to k, B raised to 0, like that. Kck, A raised to 0, B raised to k. Therefore, A plus B raised to k is equal to Kc0, A raised to k, B raised to 0 plus Kc1, A raised to k minus 1, B plus Kc2, A raised to k minus 2, B square, Kc3, A raised to k minus 3, B cube, plus Kck, A raised to 0, B raised to k. This write equation number 1. To prove that, next step is what? Prove that it is true for Pk plus 1 is true. Consider LHS of Pk plus 1, which is A plus B raised to k plus 1. Now, by law of indices, A plus B raised to k plus 1 can be written as A plus B into A plus B raised to k. A into A plus B raised to k plus B into A plus B raised to k. And A plus B raised to k from equation number 1 is this, which is what? A into Kc0, A raised to k, B raised to 0 plus Kc1, A raised to k minus 1b plus Kc2, A raised to k minus 2 b square plus Kc3, A raised to k minus 3 b cube plus Kck, A raised to 0, B raised to k plus B into Kc0, again A plus B raised to k, Kc0, A raised to k, B raised to 0 plus Kc1, A raised to k minus 1, B plus Kc2, A raised to k minus 2, B square plus k minus 3, B cube plus KCK A raised to 0 B raised to K. Now multiply A. So this will give you what? KC0 A raised to K plus 1 B raised to 0 plus KC1 A raised to KB plus KC2 A raised to K minus 1 B square KC3 A raised to K minus 2 B cube and so on plus KCK A B raised to K plus, if you multiply B, you will get KC0 A raised to KB. We will write this term just below A raised to KB. Then here you multiply, will give you what? KC1 A raised to K minus 1 B square plus KC2 A raised to K minus 2 B cube and so on plus KCK A raised to 0 B raised to K plus 1. And before this what we had? We had KC K minus 1 A raised to 1 B raised to K minus 1. So A B raised to K minus 1 into B will give you what? B raised to K. Now we'll add both the terms. So KC0 A raised to K plus 1 B raised to 0 plus KC1 plus KC0 A raised to KB plus KC2 plus KC1 A raised to K minus 1 B square plus KC3 plus KC2 A raised to K minus 2 B cube plus KCK plus KCK minus 1 A B raised to K plus KCK A raised to 0 B raised to K plus 1. Now, this can be written as K plus 1 C 0 A raised to K plus 1 B raised to 0. Let me write this next step. Let me, for the time being, keep as it is. KC0 now this you keep as it is KC0 A raised to K plus 1 B raised to 0. The sum of these two is what? K plus 1 C 1 KC1 and KC0. In lower number there is a difference of 1. The sum of these two combinations what? In upper number you add 1, take larger between the two. Now that theorem. I'll give the statement here as a reason. Again, K plus 1 C2 This is what k plus 1 C3 plus k plus 1 C k a b raised to k plus k c k a raised to 0 b raised to k plus 1. The reason is NCR plus NCR minus 1 N plus 1 C R. This reason we have given for the state which we have used. Now KC0 is what? 1 and K plus 1C 0 is also 1. Rest keep as it is K plus 1C1 plus K plus 1 C2 K plus 1 C3 plus K plus 1 CK K plus 1 C K plus 1 A raised to 0 B raised to. Reason for this state is what? Since KC0 is same as K plus 1 C0 and both are equal to 1, and KCK K plus 1 C K plus 1 both are equal to 1. This is the reason. And this is nothing but RHS of PK plus 1. We have started from LHS of PK plus 1. This implies PK plus 1 is true. Therefore, by method of induction, the given statement Pn is true for all n belongs to natural number. That is A plus B NC0 A raised to n plus NC1 A raised to n minus 1B NC2 A raised to n minus 2 B square plus NCM B raised to n. This is the proof. After this, general term in the expansion of A plus B raised to n since a plus b raised to n is what? nc0 a raised to n, b raised to 0 plus nc1 a raised to n minus 1 b plus nc2 a raised to n minus 2 b square plus nc3 a raised to n minus 3 b cube plus nCn a raised to 0 b raised to n. Here P1, that is first term, is nc0 a raised to n b raised to 0. P2 is what? nc1 a raised to n minus 1 b. P3 is what? nc2 a raised to n minus 2 b square. P4 is what? nc3 a raised to n minus 3 b cube. Proceeding in this manner, we get P r plus 1. You can see in fourth term it is 3. Third term 2, that is 1 less. Second term 1, that is 1 less. First term 0. In r plus 1th term it will be what? NCR 1 less. A का power n minus 3, n minus 2, n minus 1, n minus 0. Here A का power n minus r. B का power same number 2, 1, 0. Here B का power r. This is general term. In the expansion of a plus b raised to n. The next is middle term in the expansion of a plus b raised to n. There are two cases. Case 1. When n is even number, that is power is what? Even number. For example, a plus b square. Number of term in the expansion is what? 1 more than the power. If power is 2, the number of term will be 3. 1, 2, 3. There is one middle term in there. And position of this middle term is what? In power 2, add 2 divided by 2. 2 plus 2, 4. On to what? Second term is what? Middle term. First, second. When power is what? 4, number of term is what? 5. 1, 2, 3, 4, 5. There is one middle term. And position of this middle term is what? Power 4. Add 2 divided by 2 will give you third term. You can see third term. If power is 6, there will be 7 terms. 1, 2, 3, 4, 5, 6. There is Second term. There's one middle term and position is what? Fourth term. 6 plus 2, 8 upon 2, which is fourth term. In this case, there is one middle term position of middle term is what? In power you add 2 upon 2th term. 10 plus 2 upon 2th term is what? Middle term. Case 2. When n is odd number. For example, say power is what? 3. There will be 4 terms. 1, 2, 3, 4. There are 2 middle terms. Second and third. In 3 you add 1 upon 2. 4 upon 2 is what? Second term. And in 3 you add 3. Third upon 2. 6 upon 2 is what? Third term. The second and third are middle terms. If power is what? 5. Then the 6 terms. 1, 2, 3, 4, 5, 6. There are 2 middle terms, third and fourth. In power 5 you add 1. 5 plus 1 is 6, divided by 2 is what? Third term. In power 5 you add 3. 5 plus 3 is what? 8, divided by 2 is what? Fourth term. And if power is 7, there are 8 terms. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 6, 7, 8. There are 2 middle terms, 4 and 5. In 7 you add 1. 7 plus 1 upon 2, that is 8 upon 2, fourth term. 7 plus 3 upon 2, that is 10 upon 2, fifth term are middle terms. In this case, there are 2 middle terms. Their positions are n plus 1 upon 2th and n plus 3 upon 2th terms. So to find middle term, which numbers we are adding? We are adding 1, 2 and 3. 1 and 3 we are adding in odd number, so that it becomes even, so that it is not divisible by 2. And 2 we are adding an even number. Even plus 2 will give you what? Even number divided by 2 is possible. So odd numbers are 1, 2, 3, 1 and 3 in odd and 2 in even. Now we'll start problems. Expand root 5 minus root 2 raised to 5. It is minus and the theorem which we did for plus. So what we will do, this can be written as root 5 plus minus root 2 raised to 5. So 5c0 root 5 raised to 5 plus 5c1 root 5 raised to 4 into minus root 2 plus 5c2 root 5 raised to 3 into minus root 2 square. 5c3 root 5 square minus root 2 cube plus 5c4 root 5 into minus root 2 raised to 4. Then 5c5 root 5 raised to 0, that is minus root 2 raised to 5. In any term you see sum of powers of root 5 and root 2 is what? Always this number 5. So this is what we have to take care. Any number C0 is what? 1 and this is 25 root 5. 5C1 is 5, root 5 raised to 4 is 25 into minus root 2. 5C2, 5 into 4 upon 1 into 2, 10. Root 5 cube is what? 5 root 5. Minus square plus root 2 square is 2. 5C3 is again 10. 5. Minus cube is what? Minus. Root 2 cube is what? 2 root 2. 5C4 is what? 5. Root 5. Minus raised to 4 is what? Plus. Root 2 raised to 4 is what? 4. 1 into minus 4 root 2. So this will give you 25 root 5 minus 125 root 2 plus 100 root 5 minus 100 root 2 plus 20 root 5 minus 4 root 2. $25 plus 100, 125 plus 20, 145 root 5. Minus 125 minus 225 minus 229. Sometimes they will ask root 5 minus root 2 raised to 5 is equal to a root 5 minus b root 2 and they will ask find a and b. So a will become 145 and b will become 229. 2x square plus 3 raised to 4. 4c0 2x square raised to 4. 4c1 2x square raised to 3 into 3. 4c2 2x square into 3 square. 4c3 2x square raised to 1 3 cube, and 4c4 3 raised to 4. Any number C0 is what? 1, 2 raised to 4 is 16, x raised to 8. 4c1 is 4, 2 cube is 8, x raised to 6 into 3. 4c2 is what? 6, 4x raised to 4 into 9, plus 4c3 is 4, 2x square into 27. 4c4 is 1 into 81. Will give you 16x raised to 8. 96 x raised to 6 plus 216 x raised to 4 plus 54 into 4. 216 x square plus 81. Next is root 3 plus 1 raised to 4 minus Now this problem I will do by theory method, and the next problem I will do by shortcut method, exactly similar type. So this root 3 plus 1 raised to 4 is what? 4c0 root 3 raised to 4, 4c1 root 3 cube. 1 का any power is 1 or just write 1. 4c2 root 3 square 1 square. 4c3 root 3 into 1 cube plus 4c4 1 raised to 4. 1 into 9, 4c1 is 4, 3 root 3, 4c2 is what? 6 into 3, 4c3 is what? 4, root 3, 4c4 is what? 1. 9 plus 12 root 3 plus 18 plus 4 root 3 plus 1. 9 plus 18, 27 plus 1, 28. 28 plus 16 root 3 and root 3 minus 1 raised to 4. Because of this minus sign, now we can write directly alternate plus minus. First term is plus 4c0 root 3 raised to 4 minus 4c1 root 3 cube plus 4c2 root 3 square minus 4c3 root 3 plus 4c4. 1 raised to 4 is 1. This is 1 into root 3 raised to 4 is what? 9 minus 4 into 3 root 3 plus 6 into 3 minus 4 into root 3 plus 1 will give you what? 9 minus 12 root 3 plus 18 minus 4 root 3 plus 1. 9 plus 18, 27 plus 1, 28 minus 16 root 3. Therefore, root 3 plus 1 raised to 4 minus root 3 minus 1 raised to 4 will give you 28 plus 16 root 3 minus 28 minus 16 root 3. When you open the bracket, 28 minus 28 will get cancelled. 32 root 3 is the answer. Now further problems of this type will do by shortcut method, where we will be using basically root 3 plus root 2 raised to 6 plus root 3 minus root 2 raised to 6 is what? 970. See the proof. Consider root 3 plus root 2 raised to 6 plus root 3 minus root 2 raised to 6. In this case, there will be 7 terms and all terms are positive. In this case also there will be 7 terms and alternate plus minus, and the terms will remain same because A and B are same. So here I write T1 plus T2 plus T3 plus T4 plus T5 plus T6 plus T7. Whereas here T1 minus T2 plus T3 minus T4 plus T5 minus T6 plus T7. Now you can see even terms are negative. So even terms will get cancelled and we will get 2 times odd terms, T1 plus T3 plus T5 plus T7. All even terms will get cancelled. Even terms will get cancelled, we will get odd terms. How will write T1 T R plus 1 form. T3 can be written as T2 plus 1. T5 can be written as T4 plus 1. And T7 can be written as T6 plus 1. Now apply TR plus 1 is what? NCR A raised to n minus R B raised to R. This formula we will use. So 2 times n is 6 C 0 root 3 raised to 6 minus 0 and root 2 raised to 0 plus 6C2 root 3 raised to 4 into root 2 raised to 2. 6C4 root 3 raised to 2 root 2 raised to 4 plus 6C6 root 3 raised to 6 minus 6 0 into root 2 raised to 6. We applied the formula TR plus 1 is what? NCR A raised to n minus R B raised to R. Now simplify this. 2 times 1 into root 3 raised to 6 is what? 27 into 1 plus 6C2 is what? 6 into 5 upon 1 into 2. 30 upon 2 is what? 15. Root 3 raised to 4 is what? 9 into 2. 6C4 is same as 6C2, which is 15. 3 into 4. 1 into 1 into 4 into 2 is what? 8. 2 times 27 plus 270 plus 180 plus 8. 35, 305, 485 will give you what? 970. So this method will follow while doing MCQ.
So next problem is root 5 plus 1 raised to 5 minus root 5 minus 1 raised to 5. So there is correction in this. Consider root 5 plus 1 raised to 5 minus root 5 minus 1 raised to 5. Now this contains 6 positive terms, whereas this contains 6 alternate plus minus. So the terms are T1 plus T2 plus T3 plus T4 plus T5 plus T6. Whereas this contains alternate plus minus. So T1 minus T2 plus T3 minus T4 plus T5 minus T6. When we'll open the bracket, minus T1, minus T3, minus T5 will get cancelled. We'll get 2 times T2 plus T4 plus T6. 2 times T2 is what? T1 plus 1. T4 is what? T3 plus 1. And T6 is what? T5 plus 1. And I already given TR plus 1 as what? NCR. A raised to B raised to R. This is 2 times T1 plus 1 is what? 5C1. Root 5 raised to 5 minus 1, 4 into 1 raised to 1 plus 5C3 root 5 raised to 5 minus 3 is what? 2 into 1 cube. 5C5 root 5 raised to 0 1 raised to 5. Two times 5C1 is what? 5 into 25 plus 5C3 is 10 into 5 plus 5C5 is 1 into 1. 125 plus 50 plus 1, 176. 2 into 176 is 350. Next one is find the value of 1.1 raised to 5. This can be written as 1 plus 0.1 raised to 5. 5C0, 1 raised to 5. Now 1 raised to any power is what? 1. Will keep on increasing the power of 0.1. So 5C2, 5C1, 0.1 plus 5C2, 0.1 square, 5C3, 5C3, 0.1 cube, 5C4, 0.1 raised to 4, 5C5, 0.1 raised to 5. 5C0 is what? 1 plus 5 into 0.1. 5C2 is what? 10 plus 10 into 0.001. 5C4 is what? 5. 0001. 5C5 1. Will give you 1 plus 0.5 plus 0.1 plus 0.01 plus 0.0005 plus add then 61051. The next problem is what? 0.9 raised to 4. 1 minus 0.1 raised to 4. In this case, alternate plus minus will come. So 4C0, 1 raised to 4, minus 4C1. 1 raised to any power is what? 1. So you just write 0.4C2, 0.1 square, minus 4C3, 0.1 cube, plus 4C4, 0.1 raised to 4. 4C0 is 1. 4 into 0.1, 6 into minus 4C3 is what? 4 into plus 1 into this is 0.01. One minus 0.4 plus 0.06 1.0601 minus 0.404. 1, 10 minus 4 is what? 6. 5 minus 0 is what? 5. 10 minus 4 is what? 6. 0.6561. The next problem is, without expanding, find the value of, let A is what? X plus 1. And B is what? So this will become A raised to 4 minus 4A cube B plus 6A square B square minus 4AB cube plus B raised to 4. Coefficient is 1, that can be written as 4C0. 4 can be written as 4C1. 6 can be written as 4C2 minus 4C3 AB cube plus 4C4 B raised to 4. And this is nothing but A minus B raised to 4. This is expansion of A minus B raised to 4. A is what? X plus 1 minus X minus 1 raised to 4. When you will open the bracket, you will get 2 raised to 4, which is 16. Next is also similar type. Let A is what? 2x minus 1. B is what? 3 minus 2x. So this will become A raised to 4 plus 4A cube B plus 6 a square b square plus 4 ab cube plus b raised to 4. And 1 can be written as 4c0, 4 can be written as 4c1 plus 4c2, 4c3, 4c4, b raised to 4. And this entire thing is what? Expansion of a plus b raised to 4, which is 2x minus 1 plus 3 minus 2x. 2x minus 2x cancel. Minus 1 plus 3 is what? 2 raised to 4, which is 16. The next problem is find the value of 1.02 raised to 6 correct up to 4 places of decimals. Consider 1.02 can be written as 1 plus so take care. Here we need to find out up to 4 places of decimal. So we don't need to expand 100%. 6c0 1 raised to 6 plus 6c1. No need to write the power of 1 because 1 raised to any number is what? 1 only. Just keep on increasing the power of 0.02. 6c2 0.02 square or 6c3 0.02 raised to 3. From this only we get up to 4 places of decimals. Just to dot. 1 into 1 raised to 6 is what? 1 plus 6 into plus 6c2 is what? 15. 0004. 6c3 is what? 20. 6 places. 0, 8. When we multiply, we'll get 0.12 plus 15 for just 60. 0.006. And 1 0 will get cancelled. 1, 2, 3. 3 zeros. 1 6. 1.12 6. 1 6. We have to correct up to 4 places of decimal. So this digit is what? More than 5. So we will add 1 in previous. 1.1262 is the answer. Find the value of 0.9 raised to 6 correct up to 4 places of decimal. Consider 0.9 raised to 6, which is 1 minus 0.1 raised to 6. 6c0 1 raised to 6 minus 6c1. Alternate plus minus will come in this. 6c1 1 raised to any power is 1. 6c2 minus 6c3 plus 6c4 6c5 plus 6c6 1 minus 6 into 0.1 plus 15 into 0.01 minus 20 into 0.001 plus 15 into 0.0001 minus 6 into 401 plus 1 into 501. 1 minus 0.6 plus 0.15 minus 0.02 plus 0.0015 minus 0.000406 and 1.15 15 1515 01 0.62 006. Subtract them 1, 2, 3, 4, 5, 6. 1. 10 minus 6 is what? 4. 4 minus 0. 1 minus 0. 5 minus 2. 11 minus 6, 5. 5, 3, 1, 4, 4. We have to correct up to 4 places of decimal. 5, 3, 1, 4. Corrected to 4 places of decimal. Corrected to Thank you very much for watching the video. आज मुश्किल है, कल थोड़ा बेहतर होगा. बस उम्मीद मत छोड़ना, भविष्य जरूर बेहतरीन होगा. Today is difficult, tomorrow will be little better, and don't lose your hope. Future is always bright. Thank you.